Hello everyone, I am Rakib Hassan. I will be your host today. Welcome to the webinar. As you already know, our webinar is going to cover managing production-grade Elasticsearch cluster in Kubernetes using KubeDB. And today we have our speaker is MD Kamal Hassan, who is one of our senior software engineer who has been working with Kubernetes since a long time. So I guess we can start as it's almost past 10. So Kamal bhai, can you please start?
Okay. Hello, everyone. I'm Kamal Hassan, Senior Software Engineer at AppsCode. So today I will demonstrate how to manage production-grade Elasticsearch cluster on Kubernetes by using KubeDB. So here is my table of content. So the first question is, what is a production-grade Elasticsearch? Then the second one is why you should choose KubeDB to manage Elasticsearch cluster. Then I will show a couple of KubeDB features on the demo, and you can ask any question on the given link at the top of the slide. So at the end of the demo, I will try to answer them. So what is a production-grade Elasticsearch? A database can be called production-grade if it has the following features like backup and restore, horizontal scaling, vertical scaling, if the version can be upgradable, if the storage is full or nearly full, so that the volume can be expandable and the database is secured with TLS. And the next question is why you should choose KubeDB to manage Elasticsearch cluster. The KubeDB provides the following features for managing Elasticsearch on Kubernetes. So you can deploy combined cluster on Kubernetes where each of the node will perform as all the node roles assigned to it. You can also deploy topology cluster where you will have dedicated node like dedicated master node, dedicated data nodes, and dedicated ingest node. You can manage your TLS by cert manager on Elasticsearch cluster. You can add TLS, remove TLS, update TLS, and rotate TLS. You can automate the version upgrade of Elasticsearch cluster. KubeDB also provide automatic vertical scaling. That means your Elasticsearch cluster will automatically adjust it dependent on the load of the cluster. KubeDB also support volume expansion. That means you can expand your volume. The backup and recovery is supported by the stage operator. And the authentication and authorization is supported by the three most popular authentication and authorization plugin. It's XPack, OpenDistro, and SearchGuard. So let's jump into the demo. Let's take a look at our workstation for today's demo. We are using a Kubernetes cluster on Linode Kubernetes engine. Our Kubernetes cluster version is 1.21.1, and we have installed 3 Helm chart for our demo. Let's list them. We have the KubeDB enterprise chart for managing the databases. We have Stash enterprise chart for taking backup and restore, and we have the cert manager for managing the TLS. So this is my workstation setup. Let's deploy an Elasticsearch cluster to it. So before deploying a Elasticsearch, as I have already mentioned that we support the most 3 popular distribution, the XPack, SearchGuard, and the OpenDistro for Elasticsearch. For today's demo, we will deploy Elasticsearch using XPack auth plugin, and the version is 7.9.1. So let's take a look at the YAML. Here we have the TLS configuration, where we have reference to the cert manager issuer, which will be used to deploy the certificates for the cluster. We have enable SSL at the HTTP layer, and here is the version of our Elasticsearch cluster. We have storage type durable. That means we will use PVCs to store the data. And here is our cluster topology setup. You can see we have one master node, one data node, and one ingest node. And here is the storage setup. As we are on Linode Kubernetes engine, we will be using Linode block storage as a storage class. And we have asked for 5 gigs of RAM storage, 5 gigs of storage for the data node, and 1 gigs of storage for master and ingest node. So before applying the Elasticsearch, we need to create an issuer. So here's the issuer YAML. For the demo, I will be using self-signed certificate, but you can use your own issuer. So let's deploy the issuer first. So we have deployed the issuer. Let's get it. So our issuer is ready. Now we can deploy our Elasticsearch cluster. So you can see our Elasticsearch cluster is now on provisioning state. So on deployment of Elasticsearch YAML, the KubeDB operator create the following resources. You can see the operator has created 3 stateful set here, one for the data node, one for the master node, and the one for the ingest node. And we have few secrets here. The admin credential secret, which holds the admin username and password. And you can see we have 3 TLS secret. One is for HTTP layer, another one is for transport layer, and the last one is for archiver certificates, which can be used to take backup. So let's wait for our cluster to become ready. We have deployed the cluster with Elasticsearch version 7.9.1, but you can check the all available version by using the following command. So these are the all supported version by KubeDB Elasticsearch. You can see we have support 3 distributions, the versions from OpenDistro and SearchGuard and the Elasticsearch itself. As you can see, we use the official image provided by the distributor. So our Elasticsearch cluster is ready. Let's connect to our cluster. To connect to our cluster, we will need admin credentials. Let's get them. So the secret Proteus Elasticred holds the admin credential. We have viewed the secret. Here is our username Elastic and password is the given here. Let's export the password. So we have exported the password. On deployment of Elasticsearch, the operator also create 3 services. Let's get them. Here you can see 3 services. The first one is the client service named after the Elasticsearch instance. And the second one is the master service. It always points to the master node. And the last one is the discovery service. It helps the Elasticsearch node to form cluster. So let's port forward the client service to our local machine so that we connect to the cluster. So we have port forwarded the service. Let's check the cluster health. So you can see our cluster is created. We have 3 nodes and our status is green and the number of data node is 1. So our Elasticsearch cluster is ready to use. Let's insert some test data so we can make sure that data persists over the operations. Let's insert some test data. So we have created a demo index named products where we have provided a JSON data named KubeDB vendor apps code. Let's put some more data. let's also create some empty indexes. So we have inserted some dummy data to it. So here we have deployed our cluster with Elasticsearch version 7.9.1, but the latest version of Elasticsearch is 7.13.2. So we want to upgrade our cluster version to the latest one. To upgrade our cluster, we will need a Elasticsearch ops request of type upgrade. So all we need to upgrade our cluster is which database I want to upgrade and what is our targeted version. That's all we need to upgrade the version of cluster. Let's deploy our ops request upgrade. Here you can see that our ops request is now in progressing state. So when we perform an upgrade operation, the KubeDB enterprise operator perform it smartly. By smartly, it means it will first upgrade the ingest node, then it will upgrade the data node, and finally it will upgrade the master node. And the upgrade operation takes one at a time. That means one pod will first upgrade it, then it will join the cluster, then the next pod will start its upgrade operation. And the KubeDB operator also makes sure that the ongoing shared allocation is disabled so that no data is interrupted during the upgrade operations. So our ingest node is upgraded and is upgrading the data node. Here you can see the status is changing from ready to critical and not ready. The status ready means you can use the database. The status critical means you can connect to the database, but there are some pods that are not ready. And status not ready means you can't use the database right now. So let's wait for the ops request to become successful. Since our ingest node has already upgraded, we can check the version from inside the ingest node to make sure that it has upgraded the version. Let's check the data. So you can see that our ingest node has already upgraded to the latest version 7.13.2. So once all the pods are upgraded, you can see the ops request will become successful and this version will be updated. It's taking some time. Let's just grab it. So our ops request is now successful and cluster is back to ready again. Let's check the data. So you can see the data we have inserted earlier is still there, and the version is upgraded to the 7.13.2, and the ops request type is successful. So when we started the demo, we said we are going to deploy a production grade Elasticsearch. So you may ask that, is it natural to have single master or single data node in production grade cluster? The answer is no. So all we need to do is horizontally scale up the cluster. To scale up the cluster, we will need the Elasticsearch ops request of type horizontal scaling, where we have mentioned the new topology setup. We will have 3 master node, 3 data node, and 3 ingest node. And here is the database reference. So let's horizontally scale up the cluster. So you can see our ops request is now in progressing state. While scaling up the cluster, the operator will do almost the same thing. It will scale up the ingest node first, and it will scale up one node at a time and wait for the node to join the cluster before moving to the next one. So it will first scale up the ingest node, then it will scale up the data node, and finally it will scale up the master node. It will take few minutes. So we can talk about other feature of KubeDB managed Elasticsearch. Like we have for the demo, we have mentioned only 3 node role, like data, ingest, and master. But the recent release of Elasticsearch support the hot, warm, and cold architecture of Elasticsearch. And Elasticsearch also have the KubeDB managed Elasticsearch also have the support for monitoring. It has the exporter sidecar, which export Prometheus metrics so that you can use them in tools like Grafana to monitor your cluster and so on. Here you can see that our first ingest node is join the cluster. So we is scaling up the second one. Once the ingest node is scaled up, it will scale up the data nodes. So while the scaling up is ongoing, you can check the data from inside the cluster. That means you can still use the cluster. Let's check the data. So you can see the data is still here. You can list the shard. So here you can see our created shard are here, the primary and replica one. Since we only have one data node, the replica is unassigned. Once we will have data node more than one, it will be assigned soon. Let's wait for the ops request to become successful. So here you can see our data node is horizontally scaled up. Now the master node is scaling up. So this is the last one to join the cluster. Let's wait for it to join the cluster. The ops request will be successful soon. So our ops request is successful. That means we have successfully scaled up our cluster. Let's check the cluster status. Here you can see that our cluster status is green. We have 9 nodes, 3 of them are data. And let's check the data. So here is our data that we have inserted earlier. Let's also print the shard allocation. So here you can notice that all the shard, the primary and replica ones, are distributed in all 3 data nodes, the data node 0, 1, and 2. So all the data nodes are working. So now think that you don't need all those 3 ingest node or 3 data node. You want to scale it down because you don't need those to serve your request. So you can similarly horizontally scale down by the same ops request. Here we have provided the new cluster configuration. We mentioned that we will need 2 data node and only 1 ingest node, and the rest are the same, the horizontal scaling and the database reference. Let's apply the scale down operation to the cluster. Here you can see that our scale down is in progressing. The KubeDB operator will scale down the ingest node first, and then it will scale down the data nodes, and finally it will scale down the master nodes. So while scaling down the data nodes, the KubeDB operator makes sure that all the data shards are moved from this one to the rest node, so that no data is lost. And while scaling down the master node, the KubeDB operator makes sure that it was excluded from the leader election, so that the leader election is not interrupted. So we have scaled down our ingest node to 1, and it will scale down the data nodes. You can see the node 2 is in terminating stage. Our cluster will be, our ops request will be successful soon. So our ops request is now successful. Let's check the shard allocation now. Now you can see that all the data shards are now distributed in data node 0 and 1. All the shards from data node 2 now move to this 0 and 1 node. Let's check the data also inside. So here is the data which we put earlier. So our data is intact. So we have demonstrated the horizontal scale up, down, and upgrade operation. Now we will demonstrate how to how to take backup and restore the data for Elasticsearch cluster. So we will use Elasticsearch operator by apps code to take backup. So here is our running Elasticsearch cluster. So we will take our backup on Google bucket. So I can show you that. We have a bucket, Google bucket named KubeDB testing, and we have a subpath called Elasticsearch, and the data will be backed up in this store. So all we need to create first of all, we need to create a secret with the Google service account credential. Here we have the restrict password, Google project ID, and the service account credential that will be used while taking backup. Let's create the secret first. Once we have created the secret, we need to create a backup repository. You can take a look at the YAML. Here we have mentioned the backend where we're going to take the backup. The Google Cloud Storage, and the bucket name is KubeDB testing, and our subpath is Elasticsearch, and the secret name that we just created, GCE secret. Let's create the repository. So we have created the repository. Now we need to create the backup configuration for our Elasticsearch cluster. So let's take a look at the YAML. So this is how a backup configuration YAML look like. Here we have mentioned the schedule that we will take backup at every 5 minutes. And this is the task name that will be used to take the backup. And here is the repository name that we just created. And under the target section, there is the app binding reference. So what is an app binding? When we deploy Elasticsearch using KubeDB, the operator also create a app binding named after the same Elasticsearch instance. The app binding hold all the connection information and credential information that required to connect to the cluster. So the app binding will have the credential, the path, and so on. This is the app binding reference for our database, and here is the interim volume template, and here is the retention policy where we have mentioned that we want to keep the last 5 backup. So let's deploy our backup configuration. So we have created our backup configuration. It will schedule a backup session at the 5 minutes, but you can manually trigger the backup. So we are going to manually trigger the backup for the demo by using a backup session. So we have triggered a backup, which is now in running state. Let's wait for it to become successful. So our backup is succeeded. We have successfully taken the backup. We can also confirm from the bucket. Here is our bucket. Let's refresh it. So you can see the data. It's all encrypted and backed up. Now that we have taken the backup of our cluster, we will restore from the backup to a fresh Elasticsearch cluster so that we can make sure that the data is being restored. So before deleting the cluster, let's pause the backup configuration so that the existing backup is not corrupted. So our backup configuration is paused. Now let's delete our cluster, Elasticsearch cluster. So here you can see the error that the deletion is not permitted. This is an intentional error. This is an extra layer of protection to prevent accidental deletion of your cluster. If you want to delete your cluster, you need to make sure that your termination policy has been changed. Let's change that termination policy to wipe out before deleting the cluster. So our termination policy is changed. Now let's delete the cluster. So our Elasticsearch is deleted. You can see it from here. Now we will create a fresh Elasticsearch with the new version, latest Elasticsearch version. Let's create a new Elasticsearch. So we have deployed a Elasticsearch with the latest version 7.13.2. So once the Elasticsearch is ready, we will restore the data from the previously taken backup to this cluster. So let's wait for the cluster to become ready. Let's get the new admin credential. Let's export it. It will be soon ready. So our Elasticsearch is ready. Let's port forward the client service to our local machine. Let's check the cluster health. So you can see the cluster health is status is green. Let's check the data if there is any data already in there. So there is no index name product. That means our cluster is empty. Let's also print the shard allocations. You can see there is no shard in it. So it's time to restore the data. To restore the data, we will need to create a restore session. Let's take a look at the YAML. So here is the YAML of restore session. We need to mention the repository that was used to take the backup while restoring the data, and we also need to make sure the app binding is the correct one, which is pointing to our Elasticsearch database. And here is the interior volume template. And in the rules section, we have mentioned the snapshot to the latest one. That means we want to take the restore from the latest snapshot. Let's deploy the restore session. So the restore session is created. You can see it running, and here the status is also changed to the data restoring. That means the data is restoring to our Elasticsearch cluster. Now let's wait for it to become successful. So our restore is succeeded and our cluster status is back to ready. Now let's print the shard allocation again. So here you can see that our new shard allocation, which is distributed in data node 0 and 1. Let's check the data. So here you can also see that our data is still here. That means we have successfully restored our data. So thank you, everyone. This is the demo for today. So we can back to our slide. Now you can ask a question if you have any.
Thank you very much, Kamal.
Yeah.
I had a question on the, as you said in the beginning, about the volume expansion. I was wondering if it depends on the cloud provider you are using. For example, if we are on vSphere infrastructure with a vSAN, or let's say we have a block storage, and does it work with that as well, or you haven't tested on it?
Yeah, the volume expansion feature depends on the which storage class you are using. If your storage class support the volume expansion, that will work for you. You need to check your storage class if it support the volume expansion or not. If it does, then the KubeDB will allow it.
Okay.
Okay. So anyone else have any question?
Please feel free to ask if you have any query. Okay, so it seems no one has any query as our webinar was so good. So we'll just move to the next slide. And we're going to announce our next webinar, which will probably be in between, somewhere between July. So in the upcoming two to 3 weeks. And the topic will cover managing production grade PostgreSQL cluster in Kubernetes using KubeDB. Hope to see you guys there.
Okay.
Thank you for joining.
Thank you very much for the demo.
You,
it was very interesting.
Hope to see you in the next webinar as well.
Okay. Thank you. Bye.
Thank you very much.
Thank you.